So today what we're going to do is we're going to talk about forming the question when you're creating a statistical experiment. And the question can be anything, but usually what's happening is we're going to be looking at, because we're going to actually do an experiment. So we're going to be giving some form of treatment. So, and we'll talk about that a little bit in the video as well. But this is going to look very familiar. When we did the other stats papers, we started off with, I wonder if, and that's pretty much what you're going to do now. So remember those pieces of the question, and you're going to get a little format in the video. It's pretty much exactly the same. So remember, we asked our question, giving who and the when and the what we wanted to measure, including any units. Then we answered why we thought that it was important to ask this question. Then we did a little research about the question, and we did a hypothesis. So nothing new here when you're forming the question. The format of the question stays pretty much the same as it did for any other statistical investigation. Most of it doesn't change. So you're going to see in the video she uses terminology and exactly the same format. So if you want to use the past format from the other papers and put those together, it still will work here. So we're going to look at a short video about forming the question, which is going to talk a little bit about treatments, and then we're going to let you have a couple of go at forming some questions in the workbook. Okay? So let's just go on to the video. Go. So this is our plan, the question. Okay.
Going to look at now doing our plan for the experiment. This is quite a big section of our experiment, so make sure there's a lot of detail that we specifically need. So some of the things that we specifically need
I think
is
I
we
put
need
down the
to know
wrong
what
video.
our experimental units are.
Don't want to do plan, we want to do question, don't we? The problem. I've missed my P's. Remember, it's PPDAC, so I missed my P's. Let's try this one instead. Can everybody hear?
A problem for an experiment. The things that we need to make sure that we have in there is we need to talk about the groups. So what's our treatment group, our control group? We need to talk about the measure. So what is it that we are measuring? Is it the height, the length, the response rate, whatever it is, what's the measurement that we're making? What is the population? So we've got to describe that quite specifically. And we need to use this word effect in there. So that comes from the whole idea of an experiment, is that we're trying to look for this whole idea of cause and effect, okay? So like this little picture shows, giving an injection, that's the cause. The effect is that we see somebody crying, okay? So the injection causes the tears, cause and effect. We've also got to have a purpose and make a prediction. So if we're doing an experiment looking whether senior students can stand on either their dominant leg or non-dominant leg. Now what I mean by that is dominant is if you are right-handed, then your right side of your body is the dominant side. If you're left-handed, your left side of your body is dominant. So most people, there's about 90% of people that are right-handed and 10% that are left-handed. So we're talking about
keeps doing that.
Standing on your stronger leg, okay? And I think that, so my question is, I wonder if standing on your dominant leg has an effect on the length of time you can stand on this leg. So what we've got there is I'm talking about standing on my dominant leg, so that's going to be one group. And so I'm going to have a group that stands on the dominant leg and a group that stands on the non-dominant leg. And I wonder if that affects the length of time. So there's my variable, the length of time with the units. And I've given the population for senior students in 13 stats at Macquarie High School 2016. Okay.
Okay, so you're going to see that question. Oh, fun. Okay, you see that question looks very similar to what we've done before. I wonder if, right? And then there's your naming what if. But this time, instead of saying the median length of time, we want to see if one thing has an effect. So So you're going to use that. Make sure you use that word effect in this time instead of the median length of time. So I wonder if standing on your dominant leg has an effect on the length of time. So here you're measuring the watt in the end with its units, the measurement, that you can stand on this leg, and make sure that you give a complete description of your population for senior students at 13 whatever Macaulay High School. So here you would say for whatever grade level we get, because we're just going to ask teachers to allow us into their classrooms to work on these, and describe the population where and when. Okay, so it should look very familiar to you.
Okay, so there's my investigation question. To come up with a purpose for this, it might be that as a PE teacher, I want to know if one side's stronger than the other, because I'm looking at whether I need to build up the strength on one side of people's bodies, students' bodies, or the other, or whether I can expect both sides to be pretty equal in terms of strength. So to test it, I'm going to make them stand on their dominant leg or non-dominant leg to see if there's any difference. So there's my reason for wanting to investigate this particular question. I'm going to make a prediction, and I'm going to say that I think that they can stand on their dominant side longer, because that's the side we use more. So when I take a step, I'll usually step forward with my dominant leg first. So my hand, if you look at the muscles in your hand, the muscles on one of your hands are slightly bigger than the other. Same with your feet. When you go to try on shoes, often you'll find one foot is slightly bigger than the other. That's because you've got one side is more dominant, so the muscles and the bones are a little bit bigger because you use them more. Okay, so that's what I'm doing. I'm predicting this because, and I'm giving a reason for that, and then I've gone to find some research to support that. Okay, and I've got a...
So that prediction is just our hypothesis. In the other book, they use the exact same ideas, but they use a little bit different terminology. So it's the same as our hypothesis.
Quote, I've got the reference down the bottom of where it's come from. So I'm finding a quote that matches everything that I'm just talking about there. And there's my definition of my...
Okay, so here she's given a link to where she found this advice, and she just put it at the end. Okay, so make sure that you use some kind of notation to tell us where you found it. You can just put this in a bracket, parentheses, at the end of the quotation. It doesn't really matter. You could put it at the end and use the little 1 or 2 if you use more than one source. One source is fine, though, for this particular paper, and then just describing it. Now, she's got quite a long piece of research here. It doesn't have to be this long. One paragraph is fine. Okay?
Problem.
Oh, well, back to Tom and Jerry. Okay, so you see that is incredibly similar to what we've done in the past when we did these statistical investigations, when we were comparing the medians and looking at the graphs, and we're going to be doing exactly that this time as well. So what we're going to do is you're going to work in your workbook, pages 8 through 10. Just get practice making sure that you know those pieces of the problem section, what you need in there, okay? And think about how you can write that. Now, we're going to have lots of different experiments. We're probably going to, like I said yesterday, we're going to give you an experiment that you're going to use, but she's going to give you some ideas so you can try some of those. Okay? All right. Let me stop the recording.